we're going to see the whole structural package of CYPE, from concrete structures, composite structures with steel, some timber connections, some timber structures, foundations, steel detailing, all will be covered here. We'll try to go smoothly through it. There's a lot of information, so it might take a minute. First, we're going to introduce ourselves. I'm Aitor. I'm a country manager for some countries in the international time of CYPE. And my companion here, David, he's one of the technical experts in CYPE. He's an architect by trade. He does a lot of engineering. And you're lucky that we have him here because he's leaving from Asia in a few days. So, David, thank you for being here. Okay, so BIM server, right? So this is a platform where all the magic happens. This is where the information is. This is where the projects are stored. You can download the softwares. So David, why don't you go navigating this a bit? This is the home of the BIM server. You have projects, you have contribution, you have shared projects. More or less, this is where the projects are. You don't own all the projects. Sometimes you just make contributions on them. Different files can be stored here, the native files, some exchange files, IFCs, PDFs. Different people have access to different things, but this is kind of on the project management side of things. We are not going to go too deep into this. This is just information or where things are, and just for people to visualize how the information will be stored once they finish their part in the structural design. Okay, so I think we can jump straight to the software, right? One of the things you can do here is open the BIM server store, and we have a lot of software for a lot of different things. And navigating this for a newcomer may be a bit confusing. So at the top, you have tags that you can turn on and off to see exactly what we're talking about. In this case, we're going to talk about structural analysis. And in here, we have a lot of different softwares that do a lot of different things. We can make custom lists. Once you are in the BIM server, you can create your own application list and include the softwares you want there. You'll be able to download all the softwares that you put in this list together. But for now, it's just a way to classifying and having some control in what exactly we're talking about. We're going to use one of these to show what the softwares are going to cover. So, okay. These are all the softwares that we're going to cover today. Just for people to make an idea what they're going to see, CYPECAD does structures mostly floor by floor. CYPE3D does 3D modeling in a more free 3D space, so you can design more steel-oriented structures. Portal Frame Generator is a tool to help CYPE3D design portal frames in a really smooth way. They work really closely together. And then we have CyConnect. It's one of our specialized tools, more scientific tools to do connections. Sometimes you have standardized connections that CYPE3D can solve by itself. Sometimes you want to go deep and design something not particularly standard. So you can design it here, analyze it through finite element analysis, and go deep into exactly what you want, and making sure that connection will hold the pressures and the loads that you will import from those softwares. And then you have TrueBeam Steel for steel detailing, and embedded walls, box culverts, and cantilever walls that sadly cantilever walls still not in BIM server, but I'll tell you how to download later. For more of a infrastructure or civil engineering side of things, you can do auxiliary engineering for infrastructure, linear roads, stuff like that. So we'll come to that later. Okay, so this is BIM server. I want to show you how to access information here in case you are, for example, interested in CYPECAD. You click in CYPECAD anywhere in the BIM server and it will lead you here. This is the website BIM server, but the application website is called Info CYPE and then the name of the software. You can access this website, which is where all the information is stored. I think this is really important for people to understand how to navigate this website. If they want to get information out of any software in CYPE, they go into this website. It will be the same interface in all the software. We have different pages people can go to. In Info CYPE, you can see a lot of technical information of the software. You can see from which norms it has to different functionalities it has, where the buttons are, what the interface is, what the outputs are. All the information is here and it's really useful for newcomers. If you want if you want information on how to use the apps, this is the button to click, Learning Resources. And here we have different places to go. We have manuals and other documents, but I personally recommend to go into videos, tutorials, and webinars. That's where most of the, I think, easily accessible information is. You have webinars like this one. This webinar will be here. You have more technical webinars. You have news, short views, a lot of information about the software. David is showing there the webinar gallery. In case you want to see any other webinar about any other thing, it's my favorite way to learn and my favorite way to discover things, to see webinars, people talking to me, explaining things. I can have it in the background. So the webinar gallery is the best place to find webinars of CYPE. It has a search engine. You can search for structures, for example. On the left, you have tags. If you want to, for example, learn about a specific software or interoperability, you have there structures, architectural stuff. We have different modules that do different things. This is a good place to navigate and find information about all the softwares we have and see the interfaces, see the buttons, see what they do live. I think that's a good way to kind of get a hold of different things. If there are information here that you can't find, if you want to do something that you can find information and you don't know how to do something, you can contact technical support. There's a lot of ways to approach us, but the easier way is just through this website. We have contact forms, phone, email. We are really accessible. If you can't reach us, this is probably the best place to start making inquiries in case you have problems. Okay, so I think this shows a bit of our environment. This shows a bit of where the information is, different ways to start discovering information about us. So I think now, David, we can jump straight to software, straight to the different programs. So if you want to take the reins of me.
Sure. Thank you very much for this brief introduction. And now what we're going to do is we're going to take a stroll throughout all of the solutions that we have with some examples so you can get an idea of how you could apply this software to your day-to-day use. So first of all, if you want to start with a structural model, we can start off of CYPECAD. And with CYPECAD, we can design both steel structures as well as reinforced concrete structures. And the main approach that we use is that we work with a floor-by-floor based model, as you can see in here. And all of the data can be either modeled from scratch, as you can see in here, or if necessary, we can always load DXF and DWG drawings as well. Besides that, you can also import an architectural model that you may have modeled previously, either with CYPE Architecture, which is our very own architectural modeler that we provide for free, or if you have a model already in a third-party modeler, like let's say, for example, Revit, you can always export an IFC file directly to BIM Service Center, so you will be able to reuse all of this data. For example,
as a small pointer, we not only have a Revit connection, we have a tool called BIM Updater, IFC Updater. It's on the BIM server, and it can update from any 3D modeler. We're showing Revit because many people use it, but if you work in ArchiCAD, if you work in Allplan, it will work exactly the same. We have an IFC uploader, just export to IFC, and from IFC go straight to here. David, sorry, go on.
Oh, thanks for the note. So as you can see, for example, in this case, in this architectural model, we have some basic structural data, like for example, we have some beams, walls, columns, and so on. And we will be able to reuse this data to generate our analytical model if we want to. So you can see in here that I've exported all of this data to BIM Service Center. And then I started a new project on CYPECAD where I've reused all of these to generate this analytical model that you're seeing in here. And so once we have our analytical model, we will be able to perform our structural analysis. With a click of a button, we will be able to size all of the elements, add the rebar, check it against the building code I have selected, and of course generate all the reports and drawings. you will see that in CYPECAD, because we are working with a 4x4 based approach, we'll be able to add all of the loads automatically. It's just a matter of selecting the building code that we're going to use. And then we can go into the nitty-gritty details. We want to add dead loads and live loads throughout all of the floors, as well as, of course, wind loads, seismic loading, and so on. You can see that we have standards from around the world. And once you apply that, the software does the rest for you. Now let's say that we finish with the analysis of our structure. So we would be able to access the results in both reports, drawings, and of course you can have a full 3D view with all of this data as well. Mind you that what we're going to see right now has been proposed entirely by CYPECAD. I haven't designed a single bar of rebar that we're going to see right now. And as you can see, we can handle different nations. In this case, we've used pad footings as well as tie beams. But of course, if you wanted to, you could work with pile caps, pile footings, mat slabs, and so on. And for the rest of the structure, we worked with beams and columns, of course, as well as flat slabs. But of course, if necessary, we could also work with coffer slabs or waffle slabs, as well as joist floor slabs, composite slabs, and the like. And of course, this is not the only way that we can take a look at the results. We can always either manually check for what CYPECAD has designed for us. So for example, if we go one floor higher, we can take a look at what CYPECAD did for this specific beam. And we can take a look at the traverse and longitudinal reinforcement, as well as all the stresses that have been analyzed with the software. And you can see that this is basically the end result. Of course, if I'm not happy with this, I can always customize it to my liking. So for example, if I wanted to edit any of the reinforcements that we have in here, I could change the number and the diameter of this additional reinforcement. And if I were to apply any changes to any of the elements that we've seen here, we will also get these applied to the final results. This is not a black box design, but instead you can see at all times what's happening behind the scenes. So you can see here that we have a full list with all the checks that we have performed for this specific element. And if necessary, we can create a full report with all of this data that we can import or export later into a PDF, HTML, Word format, and so on. This is actually being generated in real time as we're speaking. And you can see that it contains all the data for all the checks that we have previously set up in here.
So let me make a small point here, David. This is the main strength of CYPE. This is not a scientific tool, it's an engineering tool. What that means is it focuses on being productive. Once you input the geometries, once you are sure that the model you're seeing is the model or the DXF, DWG is exactly what you want, you only have to make sure the beams, the columns, the slabs are where they are supposed to be, put the loads in, and the software will automatically generate all this information for you. And this is so important to visualize. This is all stuff that will require of you. Whenever you work, you will have to make sure you have the detailing of the rebar. You will have to prove your analysis, approve the code, or they are up to regulation. This is visualized here. So it's a very, very easy way to make sure your structure, your building is up to code, and you have all the materials necessary, all the outcomes that the next step in the process, the construction team or whatever you finish your projects, your clients, they will have all the information they need, and you will be able to be done with high standard of quality very, very quick. So I'm going to emphasize this a few times. The speed of this is incredible. You should try it. Just try one time, see an example being done, and see how much time you can save. And I'm sure you'll be able to save around from 30 to 70% of the time you spend now in projects. The reports are done automatically. David is going to show you all the information he can output, the different analysis he can make, and then all of this can be made into plans. Let's see if they finish.
Of course, as you can see in here, we can also generate automatically many different kinds of reports, including but not limited to things like, for example, the detailing of the columns, frame drawings, column schedules, as well as layout plans. And at any time, we can also add a title block as well. And we will be able to export all of this data later into DWG, DXF, PDF, and so on. This is going to be generated in real time, and it's going to take only a couple of seconds, as you can see. And when we're done, if we need to carry out any changes to our detailing, that's something that we could do either internally or that we could do with third-party tools as well. We can see that I haven't drawn a single line of what we are seeing in here. And we can have full details for things like, for example, frames. So you can see with all the dimensions for all the rebar that we have analyzed previously. We can even have some title blocks like this one here. And of course, if we are working with beams, columns, and so on, we can also have section drawings like these ones, some basic bills of quantities if necessary, and we can even have pending schedules for the whole structure like these ones right here. We can also have, of course, the layout drawings for our structure and column schedules like these ones. And as I said, when we're done, we can always export all of this data into one file or multiple files, either as a DXF, DWG, or PDF file. And if we want, we can stop in here with our process, or we can go one step further, and we can share all of this data back to BIM Service Center, so we can continue working with our colleagues in our work team.
If you guys remember, we actually showed what the output looks like. Is a folder we showed at the beginning where all the information was, and everything is stored there. So you don't have to send it to anybody. You don't have to send an email. You don't have to download them and then send them to anyone. If they are your connection in BIM Server, they just need to go in there and download it.
So moving on, we also have solutions for steel structures. And of course, you can also use CYPECAD for steel structures, as we've seen before. But if you want to work freely in 3D space, you can also use Site3D, which is what we're seeing right here. And you can use it for your standard projects, like, for example, this warehouse that we have in here. Or, of course, you can always go one step further beyond, and you can use it to design all kinds of custom structures like this one that we have in here. As you can see, CYPECAD and Site3D are quite similar, so if you already know how to use CYPECAD, Site3D will roll off the tongue easy for you. And as you can see, for these kinds of structures, I can also use the portal frame generator if you want to offload part of the design process to another tool, so we can have the loads automatically added, as well as, of course, the analysis of the purlins that we're going to have on roofs as well as on the walls in here. It's just like we've seen before. It's just a matter of selecting the building code that we're going to use, and then we can export all of this data into Site3D. And here we can just add the finishing touches. Things like, for example, you can see the bracing that we have in here, as well as this additional floor that we have right around here. All of these finishing touches have been added in Site3D. And just like we did previously in CYPECAD, once we have our model ready with all the loads automatically applied, if you've worked with the portal frame generator, it's just a matter of clicking on the Analyze button. And in here, we'll be able to not only size all the elements, as you can see here with the section designs, but of course, we will also be able to design the connections according to some of the libraries that we have pre-built into Site3D. So if you want, you can design your joints either as welded connections, bolted connections, and even stressed bolt connections if necessary. You can see that we've already sized all of these bars in here, and software has automatically selected all of these bars, so they check all the checks for the building code I have selected. And just like we did before, in CYPECAD, we can take a look at the individual checks for the specific building code that we're working with. And of course, we can generate reports and drawings that contain all of this data. In this case, we've designed all of these drawings automatically with CYPE, and you will see here in the drawings that we already have all the detailing for these joints as well as for the full 3D structure and even some foundations if necessary, because in CYPE, if we need to work with flat footings, we can design them directly inside CYPE as well. So let's take a look at the drawings. And as you will see, they will be generated in real time in a couple of seconds time. And they can also contain a data block like what we've done before in CYPECAD. Let's give it a short while. And you will see that we will have the full detailing for all the joints according to the building code that we have selected. And if necessary, we can always edit the final results if you're not happy with that. And we can export it into PDF, DXF, DWG, and so on. So let's take a look, for example, here at some of the drawings that have been generated by the software. Mind you, I haven't drawn a single line of what you're seeing in here. And you can see that by default, we already have all the data that would be relevant for our construction team. So we can have all the measurements, all the specifications for welds, and so on. And of course, once we're done with all of that, we'll be able to either print all of this into one file or several files as either a DXF, DWG, PDF, and so on. And just like we did before in CYPECAD, if we want to go one step further, we can export all of this data directly into BIM Service Center. So if, let's say, we have a building like this one right here and we want to design the joints, of course, we're talking about a completely customized structure. And as you may imagine, we need a higher degree of control when we need to design these kinds of joints. And for that, we can continue with the help of CYPEConnect. Mind you that if you're working with combined structures, if you're working with, let's say, a steel structure like this one, as well as a reinforced concrete structure like this one, you can also work with both of them at the same time with CYPECAD and CYPE. In this case, for example, we've designed this structure entirely with CYPE, and then the podium that has been designed with a reinforced concrete structure has been modeled previously in CYPECAD. And you can see that we can combine the two of them at the same time, like so.
For people to visualize what we're doing, CYPECAD and CYPE functionally, they calculate similar things. They work differently because they are optimized to do one thing. CYPECAD is really, really efficient when you're designing any kind of standard building, a floor by floor with not too many inclined planes and things that go out of floor by floor design. CYPECAD is really, really efficient doing that. It can do steel stuff, but it's designed with buildings in mind. CYPE is more of a free modeler of 3D structures, and 3D structures are mostly done by steel. So it's not about functionality, it's designed to do a specific workflow very, very efficiently, and they connect inside CYPECAD. There is a window inside CYPECAD that allows you to design inside 3D. So both softwares are the baseline of, if you're designing any kind of structure, any kind of building, any kind of sculpture that needs footings, that need grounding, both of them can solve it. Portal Frame Generator is a support tool for CYPE for doing another very specific thing, warehouses and stuff that needs panels. And it will do it very, very efficiently, again, with efficiency in mind. So with those three programs, we've covered what most buildings will ever need. We're going to jump into CYPEConnect and StruBeam Steel. Both of them, CYPEConnect can help in the earlier discussed workflows, but they are mostly designed for steel and steel detailing and some timber connections for timber structures. But I want people to visualize how we have a specific tool for a very specific thing, and that's a way of being efficient.
So now that we've taken a look at reinforced concrete structures and steel structures, what happens when you need to go one step further and then customize all of the joints that we're talking about? Well, you have CYPEConnect, which allows you to design and check all of your joints according to a finite element analysis engine developed by the University of Berkeley, California. And you can see that it supports all the different building codes that we have, including, of course, the Euro code, British standard, American standard, Indian, and so on. And in CYPECAD, we can work with steel as well as with timber and concrete, because we can design either steel joints, or if we needed to, we could create also timber joints like this one that we have here, as well as combined ones with steel to timber or steel to concrete and so on. And basically what we do in CyPECAD is that we can import the model that we have generated previously with Site3D or with any other steel modeling tool. And from then on, we will be able to design step-by-step all the different joints that we have in here. I've already done this previously, and let's take a look, for example, at this joint that we have right around here. So we'll be able to design it step by step. So when we start in CyPECAD, what we have is a blank slate, so to speak, and it's just a matter of adding a series of operations that you can see on the top left on my screen right now. So you can start designing step by step your joint. You can work with things like, for example, bolts, welds, openings, anchors, stiffness, and so on. And of course, if we're working with timber elements, we can also work with dowels, bolts, and screws. And there's also operations to adjust and trim your bars as well as adding plates, either freely or at the end of our joint in here. So in this case, what I would have to do is, first of all, solve all the clashes that we have in here. And we could do that, for example, with a front plate like this one. All of the properties of all the operations that we have in here can be customized. You can see I can change the thickness and the overhangs of this specific front plate. And of course, I could either manually add the welds, or I can add them automatically as well, as you can see here. All of the properties of these elements can be customized as well. So if I wanted to change, for example, the kind of connection that we're going to have, if it's going to be either a fillet, butt, or lap joint, or if I wanted to change, let's say, the throat thickness or the initial and final displacement as well, that's something that I can take into account. I could continue in this specific case, for example, with an adjustment to section V2, so it's not clashing with the web of section V1. And I can also add some trims as well that you can see here. We can have either with core radius, trill, or straight. And in this case, I'm going to work with an articulated joint. So I'm going to add a plate like this one, which could be either attached to any of the sides of our section right here, or it could be either working freely in city space if necessary. I'm going to add another weld as well. And of course, we can also have bolts. As you can see, in this case, I've added them manually, but if necessary, I can use the bolt generator in here. And this bolt generator is going to use the axis of our local plate, like so. You can also customize, of course, the materials that we're going to use for our bolts as well. And once I'm done with the designing process, I can just continue on either creating my own connection library, so I can export all of that and reuse it in as many projects as necessary. And I can continue with the analysis. We work with the OpenSys engine developed by the University of Berkeley, California, and all the loads and load cases can be imported from the BIM model that have been generated previously with Site3D or any other modeling software for that matter. And when we click on any of the analyze buttons I have in here, either for stress, strain, rotational stiffness, or buckling, you will see that our structure will be simplified into discretized elements. That is, for example, plates, as well as the flanges and webs of our sections will be turned into shell elements. as well as, for example, the welds are going to be turned into point elements, and the individual bolts that we have as well will be turned into spring elements. So we want to have a visual assessment of our analysis, we could do so in here. And we could take a look at the stresses and deformations according to the formulas stress, for example. And you can see here that we have the discretized model. As you've mentioned before, CyPECAD is a more scientific tool, so to speak, where you are in touch with the actual results of your analysis, so you can have a further understanding of what's happening behind the scenes. And when you're done with the analysis, you could either generate a summary with all of the data according to this project, or you can take a look at some of the checks that we do according to the building codes that we have set up previously. Just like we did before, we can export all of this data, if necessary, into a PDF file, HTML, Word, and so on. And this is the only tool in the market that can also generate automatic drawings for these kinds of joints. As you may imagine, we're working with custom joints, so there's no predefined views, so to speak, that we can use. But it's very simple to do so. You could create a new sheet like this one, and we could insert some predefined views like the ones that we have in here. So it's just a matter of populating the drawing with things like, for example, smart tags, which read all of this data off of the BIM model, as well as measurements. So if any of these elements were to change, if we were to update the properties of these joints, the data that is linked to them with the smart tags would be updated as well. And once we're done, we will be able to export all of these, of course, into drawings, either to PDF files, XF, DWG, and so on.
So I'm going to make a small point here again, and I focus a lot of what the client will see. So close that window, please. So what did you do in this software? The geometries of the bars were imported, so you don't touch that. The geometries, where the bars are, how they interact with each other, that's imported of Site3D. You don't do the analysis, and you don't do the outputs. The only thing you do is the actual process of how the two connections interact, or the three in this case. I think there were three beams interact. That's the only thing. This process is the only thing you do. That's where you apply your expertise. The inputs and outputs, the manual labor, the boring part, in quotes, that's done automatically by the software. So you only apply your expertise. You make sure that you put your value in there, and all the small things, all the wastes of time are discarded. So you work as efficiently as possible. You just do what they pay you to do, and all this designing of how do you want to do the layouts and try to make it beautiful and stuff like that, that's done by the software. So it's a way of you do the work that you paid for, and everything else is done by the software. So I think it's important to focus on that. The loads are important too from the other softwares. So it's a way of making sure that this works very quick.
And of course, for all the steel detailers that we have in here, we also have stream steel. And the beauty of stream steel is that if you already know how to use CyPECAD, you also know how to use stream steel, because we use exactly the same modeling process. And actually, if you want to check if any of the changes that you've done to the analysis have been reflected into this new model, that's something that you could do as well. So you can have, so to speak, CyPECAD inserted inside stream steel. So once you have all your joints modeled, you can also create parts, assemblies, and joints. So you can see here, for example, that we've already created some assemblies. For example, this bar right here. And we also have some joints as well, if necessary, like these new joints that we have in here for the purlin and so on. And we can either number these manually, selecting the assemblies, the parts, joints, and so on, or we can do that automatically as well when we generate composition with all the drawings. Because mind you, in Stream Steel, we are able to generate all the views that we're going to use for our steel materials automatically. As you can see, this is being generated right now in real time. And the final output would be a series of drawings, like the ones that you're seeing here for individual parts, where you can add some very basic bits of quantities, as well as title blocks, and so on. And of course, you can have drawings for assemblies, like the ones that we have set up before. You can see that they already contain all the data that is relevant for the steel detailers. And of course, like in CYPECAD, you can also have detailing just for a specific joint. And of course, you can have the full drawings for the structure, like the ones that we're going to show you right now. All of this is being designed by the software. All of these drawings have been drawn by the software, and we can always customize them with all of the drawing elements we have in here. And of course, if we are happy with the final result, we can always print that as well into a PDF, DXF, DWG, and so on. This is not the only kind of output that we can have in Stream Steel, and actually, if you want to send all of this data directly to your steel workshop, you can also export all of these files into a DSTB format, STEP format, as well as IFC files with the EM11 standard. And with that, I'd say that we've already finished with the steel structures workflow that we have. And if there are any civil engineers around here, you also have tools for civil works. But of course, as we've mentioned before, it's mostly for not specific elements, like, for example, bridges, tunnels, and so on, but instead it's for auxiliary structures that may be useful for linear infrastructure and so on. And for that, if we go back to the list of tools that we have in here, you can see that we have stream embedded walls, stream cantilever walls, and stream box culverts. So let's take a look at that. Let's take a look at that. It's around here. And for example, here you can see that we have stream embedded walls. And in here, it's just a matter of setting up the different elements that we're going to use for our structure, that is the construction materials and so on. The phases that we're going to have for the construction as well as for the analysis. And then the software will do the rest. It will automatically size all of the river that we have in our cantilever wall or in our embedded wall. And it will carry out the analysis, so it will be able to check all the river that we have in there, as well as generating the reports and drawings. So for example, in here, you can see that it's just a matter of setting up all the different phases that we're going to work with. And then in each phase, we can add things like, for example, the different layers of dirt that we're going to have, which of course can be completely customized according to the stresses that we're going to have for each specific kind of soil and so on. And you can see that at any phase, we can take a look at the text that we're going to have for displacements, as well as for axial and shear stresses, bending moments, and so on. We can even take into account the water table, as you can see in here, and we can even have, if necessary, any kind of exterior forces that are going to be applied into the soil as well. When we're done with the phases, with our soil layers, and with all the different kinds of retaining elements that we're going to have phase on phase, which could be, for example, struts like these ones right here, or it can also be passive anchors like the ones that we've seen here. And of course, they can also be floor slabs like these ones. we'll be able to run the analysis and take a look at all the checks that we've performed inside of the software. If anything were to fail, as you can see here, it would be highlighted for us to check later. And of course, we can export all of that if necessary into PDF, HTML, or Word format as well. If we switch to the reinforcement tab in here, you will see that we also have all of the rebar already designed for us. And we can take a look at all the detailing that has been generated in here. We can customize the reinforcement tables if necessary, so that way we can force the program to work with one specific kind of diameter as well as spacing and so on. And when we're done with this, we will be able to export all of that also into PDF, HTML, TXF, TWG, and so on, like so. We can add title blocks if necessary. And we would have something like this. See that we can have some bending schedules as well as some very basic builds of quantities, detailing that has been generated automatically by the software as well, title blocks, and so on. And just like we did before, we can print all of these into one file or multiple files as well. If you already know how to use stream embedded walls, stream cantilever works exactly the same way. You can see that in this case, many of the UI elements are quite similar, and it's just a matter of setting up all the phases that we're going to work with. In this case, we only have this one right around here, and we can work with slope walls like these ones right here. You can set up the materials that we're going to use at any time as well. So if you want to manage the properties for things like exposure glass or the cracking checks and so on, that's something that you could do as well. And when you run the analysis, you will be able to take a look at the rebar that has been designed by the software. And of course, all the checks according to the building code you have selected. In this case, for example, we're working with the Eurocode, and you can see that at all stages we're mentioning the articles and the building code that we are working with for all the checks that we have as well. When we're done working with any of these two softwares, we can also export all of that data back to BIM Server Center if we want to work with other colleagues for things like quantity surveying, clash detection, as well as for the integrated 3D viewing capabilities that we have in BIM Server Center, as well as for our mobile tools as well, if you want to use augmented reality and virtual reality, of course. And last but not least, we also have box culverts in here, which you can either design manually or you can use the included wizard that we have in here. So if you want to easily design a box culvert like this one in a couple of minutes time, that's something that you can do quite easily. You can see that we can work with wing walls like this one. And of course, we can have a finite element model like this one with the final results for our box culvert. All of the rebar that is going to be contained into these elements is going to be designed by software, and we can add different kinds of mobile loads if necessary. So for example, if we want to add truck loads or strip loads, that's something that we could have as well. And they can be linked to the building code you're working with, or you can even go one step above and you can design your own kinds of mobile loads like so. Once you're done with your design, you can carry out the analysis, and that's where box culverts will size out the elements and check them against the building code. And you can see here that if we switch to the reinforcement tab, we already have all the reinforcements designed for us for all the individual elements that we have in here, with auto drawings, that is, of course. And if you're not happy with the final result, we can always customize the rebar that we have in here, so we can change the diameters as well as the separations between them, the anchoring lengths, and so on. And when you're done, you can export this once more, either as a DWG, DXF, or PDF file. You can add a title block like we've done before. And now I'm going to generate all the drawings for you. So you could have something like this with bending schedules, use of quantities, geometrical, as well as rebar detailing drawings like these ones. And of course, at any time, you can edit any of these elements in all of here. So if you want to change the location of any of the tags, like so, that's something that we could do. Or if you want to move any of the objects that we have in here, something that we could do as well. But most of the time, this won't be necessary, as you can see. And once we're done, we can export this into DXF, DWG, or PDF file I've just mentioned. And that would be it for the workflow that we are proposing to you if you're working with cantilever walls, or if you're working with the bed walls, like we said before, as well as with box culverts.
I'm going to make a small point about these three softwares. They may look a bit isolated, but if you're doing a road or you're doing any kind of linear civil works, you may have to do 15, 20, maybe 100 box culverts or a cantilever wall because you have an elevation that you need to clear or stuff like that. So imagine the amount of time doing repetitive and relatively easy works like this one, especially box culverts. They are so automatic that you'll be able to do all the box culverts you need to do in a couple of days instead of a couple of weeks. Imagine the amount of time that will save you in the long run. So it's a thing to keep in mind. These softwares, they may look specific, but I think they're really, really efficient and they're really good in what they do. I'm going to mention one thing before we move on. David, do you mind going back and forth and showing how many of these softwares you have open at the same time? So basically, around 10 of the modules are open at the same time. Multiple models are open in every window. So this shows how lightweight these softwares are. David is working in a computer, in our office computer, which is not a supercomputer. And he has a capability of having all of them open, doing processes, doing analysis, that you don't need a crazy computer to run this software. It's made to be efficient, even in the computer side of things. So it's a way of mentioning that all of the analysis, all the different elements that the software has, they're very, very lightweight. So they can do plenty of things at the same time. And pretty much every computer can run it. I think that's important to mention. Going from the back to the front again, box culverts, embedded walls, and cantilever walls. Cantilever walls, sadly, is not on BIM server yet. It'll be really, really soon. So we have this CYPE menu that we used to have. You can access this by asking one of the resellers or asking us directly. We'll lend you a license. If you want to try any of the softwares, you can download them for free from the BIM server. And if you make an evaluation project, you'll be able to try them out, all of them. If you have any trouble downloading, if you have any trouble starting a project, contact us. It's been a pleasure, David, always a pleasure. Everyone else, thank you for saving an hour of your time, and we hope to see you around.